Unit 3, Section 6. Today we're going to be taking a look at graphing linear equations in slope-intercept form. If you remember the slope-intercept form that we talked about a few days ago, this form y equals mx plus b. We said m represents the slope and b represents the y-intercept, so where it passes through that y-axis. Our slope, the other day we gave you the formula y2 minus y1 over x2 minus x1. And we called this the change in y values over the change in the x values. And we said the slope of a linear function or a linear equation is a constant rate of change. All right, so if we were to take a look at individual slopes here just to see what these slopes look like, we would say a positive slope always slopes up and to the right. Negative slopes slope down and to the right. And remember, we're always moving from left to right. A slope of 0 would be a horizontal line, and an undefined slope would be a vertical line. All right, let's jump into a few examples here. And it says to find the slope of each line. So there's several ways to do this. The first one here, we're going to look at just using the coordinates. So I have one coordinate here is 1, 3, and the other coordinate is -2, -3. So if I use the formula y2 minus y1 over x2 minus x1, I will calculate this by subtracting my y's from each other. So 3 minus a -3. And then I'm going to subtract the x's from each other. And since I started with the positive 3, I got to start with the positive 1 here. 1 minus a -2. All right, so minus a negative means addition. So 3 plus 3 is 6. And 6 over a 1 plus 2, which is 3, that can be reduced to 2. So we said that the slope of this line is 2. The change in the y-coordinate should be +2, while the change in the x-coordinate is +1. You may have also learned the catchy little phrase, rise over run. Just keep in mind that rise always means the change in the y, and the run is the change in the x. All right, in example 1b, we'll look at calculating our slope simply by counting our boxes when we're given this nice little xy plane. All right, so I'm at -2, 0. We're going to count down 1, 2. So there's our change in y, and that's going to be equal to -2. And now our change in x moves 1, 2, 3, 4. And that's a +4. Oops, I'm going to write change in x is +4. So -2 over 1 can be reduced to -1/2. So the slope of this line is -1/2. For every 1 that it goes down, it's going to move to the right 2. What about finding slope when we're given just these relations, these xy pairs listed in a t-chart? Well, same thing. What you want to do is you want to just pick 2 points. Let's just take these first 2 points here. And we'll start off by doing our change in y over our change in x. So my change in y, it looks like I'm going to go from 20 to 14. So if you wanted to write it as 20 minus 14, you could do it that way. Or you could just say that that's, yeah, let's just do it as 20 minus 14. Next, we're going to go from 4 to 7. So we'll say 4 minus 7. Now when we do our math, 20 minus 14 is going to give me 6. 4 minus 7 is -3. So if I reduce that, my slope here of this line will be equal to -2. All right, next up, let's take a look at this other xy plane, or this xy t-chart. And you see my x's are -3, -3, -3, -3. They're all staying the same, whereas my y's are changing. So if we were to do just 2 points here, let's take these first 2 again. My change in y would be -3 minus 0, and then I'd have -3 minus a -3 for my x's. Well, -3 minus 0 is -3, but -3 minus a -3 is 0. Now, I can't divide by 0. This is an undefined slope. And because it's an undefined slope, we know that this must be a vertical line. And that should be a little bit of a clue when you see all x's equaling -3. Remember, the equation of that line would be x equals -3. And when we have no y in our equation, it's just an x, we know that we have a vertical line, and that vertical line will have an undefined slope. All right, slope-intercept form, as a little bit of a reminder, was y equals mx plus b, and our slope was given by the number or the coefficient in front of x, that's the m variable, and b was our y-intercept. Remember, our y-intercept is when x is equal to 0. All right, let's do a few examples here, and it says example 3, simply to find the slope and the y-intercept. Well, this is pretty nice. It's given to us in slope-intercept form. There's nothing I need to do to rearrange this. As long as it's in y equals mx plus b format, I can simply read the number that's in front of x to be my slope, and the number that stands alone, the constant, to be my y-intercept. So my slope is 2, and my y-intercept is -3. However, in example 3b, I see that it's not in this nice y equals mx plus b format. So for this one, I do need to rearrange to get y by itself. So I'm going to add my y over to the right, and I'm going to subtract my 8 to the left simultaneously. So I'll have 6x minus 8 is equal to y. Now it's in slope-intercept form, even though my y is on the right. That's perfectly fine. My number in front of x is 6, and that's my slope. My number that stands alone is -8. So my slope and y-intercept can easily be read off of my slope-intercept form of my equation. And that's going to help us when it comes to graphing slope-intercept form. So here it says to graph and answer the following equations. I got y plus x is equal to -2. This is not in slope-intercept form, so we're going to get it there. So we're going to do that by subtracting over our x to the right. And when we do that, we get y equals -x minus 2. Now the number in front of x is actually -1. So I have a slope here, or an m value of -1. And I have a y-intercept of -2. And so I'm going to right away copy down -2 as my y-intercept. In terms of my x-intercept, well, remember, x-intercept is where it crosses the x-axis, and that's going to be where y is equal to 0. So we're going to substitute 0 in for y, and now solve for x. When we do that, we need to add our 2 over to the left side. So positive 2 is equal to -x, which means positive x is equal to -2. So my x-intercept is -2 as well. So kind of a fun little graph here. We got an x-intercept of -2, a y-intercept of -2, and this should show us that our slope is indeed -1. If we come down 1 to the right one, we'll be at another point, down 1 to the right one, down 1 to the right one, and now we can just connect these with a nice straight line. All right, and there is the graph of that linear equation in slope-intercept form. For our final example for today, we have a linear function g models a relationship which the dependent variable increases 2 units for every 3 units the independent variable increases. All right, so dependent, remember, is your y. Your independent is your x. So it's saying that the change in the y variable is going up by +2 for every 3 units in the change of the x variable. So change in y over the change in x should be +2 over +3. So this is the slope of my line. It is 2/3. Now it says the graph of g is g of 0 equals 2. In other words, when x is 0, my y is 2. So I know the coordinate 0, 2 is on the graph. So I'm going to plot that right away. 0 over and 2 up goes right here. So this is my y-intercept, 0, 2. All right, now from here, I can just use my slope to count rise over run. And this might be what you remember from previous courses. From this point on the graph, I'm going to rise 2 and run 1, 2, 3 and put another point down. From there, I'm going to rise 2 and run 1, 2, 3, rise 2 more and run 1, 2, 3. I have several points that I can draw a straight line through and graph that linear equation. Now, what about my x-intercept? Remember, to find your x-intercept, this is where y is equal to 0. So if we copy this back down, and we move now from right to left, if I come down 2, I got to move to the left 3, and you can see that it passes through that point, -3, 0.